Hello and welcome to this presentation. Myself Sanjit Kumar Singh, lecturer in Electronics and Telecommunication Department at PATIL College of Diploma Engineering and Technology. This is the fourth chapter, Radar Fundamentals Part 2. In this presentation, we will see the syllabus 4.3 Basic Pulse Radar System, Block Diagram and Description, Applications, and we will also see the 4.4 Antenna Scanning Types and Principles, the 4 types: horizontal, vertical, helical and spiral. Course outcome is to interpret radar based systems for range detection. Unit outcomes we have already seen: to describe with a relevant sketch function of the given component of the radar system, second, calculate the maximum radar range for the given data, third, state the effect of the radar range for the given parameters, explain with relevant sketch the given type of scanning and tracking methods used for radar communication, describe with relevant sketch the construction and working of the given microwave antenna. So here we see the basic pulsed radar system block diagram representation, a general block diagram representation in which we can see the major parts or systems of a pulsed radar system. So basically it has the antenna subsystem, then transmitter subsystem, receiver subsystem and the display subsystem. These are the four major parts of blocks of a pulsed radar system. And to control all this, we have a master timing generator. So basically a pulse radar sends high power and high frequency pulses towards the desired object target. It then waits for the echo signal from the object, the distant object, before another pulse will be transmitted or sent. The range and resolution, the distance and the finer details of the radar depends on the pulse repetition frequency. It uses the Doppler shift method in determining the moving target particularly. The principle of radar detecting moving objects using the Doppler shift works on the fact that echo signals from the stationary objects are in same phase and hence get cancelled, while echo signals from a moving object, moving target, will have some changes in the phase and will be forming loop on the display. So it will be easier to detect the moving target on the display. As we have already discussed, there are four basic subsystems: the antenna, the transmitter, receiver and display unit. We will see one by one. The transmitter in pulsed radar system consists of a magnetron, that is a high power vacuum tube oscillator which can generate microwave signal. Actually in a magnetron, the cavity size determines the operating frequency, and a magnetron can generate megawatts of power. It can generate 10 megawatt at UHF frequency. It can generate 10 kilowatt at frequency say 180 gigahertz. So the next, master timing generator, a timing circuit, is a timing generator set the pulse, which sets the pulse duration, the pulse width, the PRT and the duty cycle. The pulse duration is the duration or the time for which the high frequency signal, powerful signal is transmitted, is turned on. PRT is the time between the two pulses, and duty cycle is the ratio of the pulse width W to PRT, that is pulse repetition time. So W by PRT will give the duty cycle or duty ratio, multiplied with 100 will be the duty cycle in percentage. For example, if the pulse width is 9 microsecond and PRT, the pulse repetition time, is 120 microsecond, then the duty cycle will be 9 divided by 120 multiplied with 100, so it will be 7.5% duty cycle. Similarly, if the time period for PRT time is 120 microsecond, then the pulse repetition frequency will be 1 upon PRT, that is 1 upon 120 microsecond, that will give 8.33 kilohertz of pulse repetition frequency. So the pulses from the timing network trigger the magnetron into oscillations, and the magnetron start emitting short burst of microwave energy. Now this short burst of microwave energy may range from a few microseconds to several microseconds. It could be less than 1 microsecond to several microseconds, and the time between transmitted pulses is known as the pulse repetition time that we have already discussed. So the duplexer, next part is the duplexer. The duplexer is a special device that allows the transmitter and receiver to share a single antenna. The antenna is shared between the transmitter and the receiver, so it is done by the duplexer. The antenna, particularly the horn antennas, are used with a parabolic reflector to produce very narrow beam width. The same antenna is used for reception. During the pulse of time, the receiver signal passes through the antenna, the associated waveguide and duplexer to receive. The receiver is a standard high gain super heterodyne type receiver which will detect the echo pulses. The echo pulses could be in microwatt or even picowatt order, that can be detected with the help of a very high gain super heterodyne type receiver circuit. Display, CRT display is known as type P or plant position indicator. So plant position indicator display is that in which it shows both range and azimuth of the target. There is another display type, A scope type, A type or A scope type, which gives only the distance, the range, not the direction, not the azimuth. So here we are making use of PPI, which gives both a range, the distance, and azimuth, the direction or the angle. Basically pulse radars, there are two types of the radar systems, pulse radar and continuous wave radar, and there is another broader types, search radars and tracking radars. So now the advantages and disadvantages applications of pulse radar. Advantages include the unwanted echoes are rejected by the Doppler filters. It also offers high signal to noise ratio, and we use generally medium PRF, that is pulse repetition frequency pulse radar, which gives better range, accuracy and range resolution. So proper PRF has to be selected. Disadvantage, high PRF pulse radar is poor in performance. For shorter distance, short range radar, we can use the high PRF. We should use for a very short range radars, we use narrow pulses and shorter PRTs. For medium PRF, pulse radar does not have any clutter free region. That is a drawback, means there will be some clutters, grass like plots on the PPI. Applications: the long range distance communication makes use of pulse radar. Military applications may also use weather observation, air traffic control. Then satellite based remote sensing of Earth's surface is also making use of pulse radar system. Next part is antenna scanning types and principle. So radar antennas use either dipole or horn-fed paraboloid reflectors. These antennas are made to scan a specific surrounding area of a space by rotating it on its axis, as well as elevating and bringing back to its original position as it rotates. So scanning pattern depends on the application. The first type we see horizontal scanning. The second we see the nodding, that is also called vertical scanning. In the horizontal scanning, it is the simplest method of scanning which scans in horizontal plane only, and this type of scanning can be used for searching the horizon, like ship to ship communication or ship to ship radar communication takes place with horizontal scanning. Nodding scan, that is vertical scanning. Here the antenna is rocked rapidly as it is moving slowly about its axis in azimuth in direction. So limited sector can be scanned, as well as if increased the elevation, if the elevation is increased, we can cover the entire hemisphere using vertical, or that is nodding scanning method. Then third is helical scanning. In this, the antenna is elevated slowly but rotated fast, so, and will return back to the starting point after it has completed one cycle. For example, a typical value of rotation is 6 rpm with 20% per minute rise. The fourth one is a spiral scanning, in which the antenna can scan a limited area of more or less circular shape. So the diagrams we can see the four types of scanning types. That's it. Thank you.